Can you send me that? Never mind, I got it.
Okay, cool. Okay, I'm gonna share my screen. Well, first of all, welcome everyone to our AA Visiting School Social Algorithms Workshop Final. As I said, we have 9 students. The workshop has been 9 days, and it's been a lot of fun, although a lot of work for the students. So I know Case and I are super proud of the work that they've done, and especially like their research and understanding. But today we're going to present. We actually have 8 students going today. We're going to do it in groups of 3. So we'll talk about a couple projects. Like they'll present, we'll talk about them. Group 2 will present, we'll talk about those, and so on, and just kind of see how that goes. And we'll do like a brief introduction of the workshop so you guys get a better understanding. But for the students, first I would like to introduce the jurors. So we have, I don't know if you guys can, I'll go down my list, but Andrew Chittenden is an architectural researcher, designer, and educator in Los Angeles. He's taught and assisted courses at SCIARC and SAC Frankfurt. He received a Master of Architecture with distinction from SCIARC and a Bachelor of Arts from Yale University. And he is currently working as a computational consultant at the Gary Technologies office of Trimble Consulting. Next, we have Miro He, who is a Beijing-born educator and architectural designer and digital artist. He's currently teaching at Virginia Polytechnic Institute and State University, Virginia Tech. He was actually supposed to fly out there this morning and then is still in Los Angeles. So he is a collaborator of Testa Weiser and also teaches at SCIARC. He's also worked for Zaha Hadid Architects, Information-Based Architecture, Way Architects, and has worked with the Dream the Combine for the 2018 MoMA PS1 Young Architects program, in which they won. Next, we have Pedro Ferrazzini, who is an architect located in Rosario, Argentina. He has a degree in architecture from Rosario National University, Masters of Science in Architectural Technologies at SCIARC, where he was a Fulbright Scholar. Pedro is the Director of Innovation for Development Area at Rosario National University, professor at Valderrama Workshop at Rosario National University, and a guest reviewer at Innsbruck University, SCIARC, and FADU UNL. Oh my God, it's a lot to read up back to back for everyone. Never had to do this before. Raquel Escipione. She's an architectural designer and researcher based in Los Angeles. She has a BArch from the Polytechnic of Turin, 2 double master's degrees, MArch from Polytechnic of Turin in partnership with the University of Brasilia, and a Master's of Science from the Alta Scuola Politecnica, and as well a Master's of Science in Architectural Technologies from SCIARC. She's worked for Patterns here in LA. She's been a teacher's assistant at SCIARC, and she's currently working for SA8.0, where she recently worked on a project that is currently being shown at the Architecture Biennale in Venice. And last but not least, we have Tucker Van Leeuwenhoek, who is a multidisciplinary designer, theorist, and architectural educator based in Los Angeles. He's taught at SCIARC for such faculty as David Rue, Timothy Morton, and Dwayne Euler. He's currently teaching in the Synthetic Landscapes master's program there. He has collaborated on installations for Euler Wu, Mark Foster Gage, Daniel Liebsand, and Neil Denari. And he also works part-time as a producer and has worked on music videos, short films, and production design. So now that we have that out of the way, let's get into the workshop. So do you want to start this actually, since I just talked for like 20 minutes?
I was going to ask you if you wanted to pass off some of the load to me, but I mean, I'll let you go. No. All right. So this social algorithms asked us to do a project based on this, they gave us kind of a keyword. The word was mutation, which, can mean a lot of things. But I think we decided, based on the tools that we wanted to use, the intelligent agents and the CycleGAN, that we would look at mutation in response to, as a more of a adaptation response to a variety of pressures, such as behavioral pressures, climate pressures, and then to look at the patterns and behaviors and possibilities that might grow from those specific pressures. So we thought, based on the general tool set, that we would use infrastructure as the basis for our exploration. We did this for a number of reasons that I probably should know better than I can say right now, but the reason was mostly that they had it's been a long couple of days, was that they had, we were interested in multiple touch points, and essentially introducing kind of ideas of complexity to systems design. And we thought that by looking at infrastructure and the related data surrounding it, that we could really kind of crank up the level of complexity that the students would have to engage with, not as like punishment, but just as a kind of thought experiment. So, but in order to prevent them from going absolutely insane down the rabbit hole of kilowatt hours and gigawatts and you know, cubic meters of water and all kinds of nonsensical metrics that would probably take a PhD to unpack, we thought we'd do it in the space of speculation. So essentially what we did was we gave them a list of topics and we said, look through these things and look for things that interest you within these topics, such as climate change or energy shortage, new technologies, population increase, you know, any kind of maybe technologically mediated consumption habits, all kinds of the things that might sort of begin to manifest themselves as cities change and we move into this next phase of, like, you know, edge computing and IoT and all that good stuff that people like to talk about, but most of us, including myself, probably have very little knowledge on actually how it works. And in order to kind of, you know, wrangle that in, we gave them this basic, you know, what ifs, to create a what if statement, and then from there to create a then maybe statement. So based on the research, they would say, what if, a good example might be, what if Seoul decided to use all small modular nuclear reactors for their energy within a specific geofenced area? Then maybe they would have to, I don't know, develop evacuation plans for that scenario. You know, just a very simple thought experiment that would allow them to penetrate a rather complex, you know, thought area. So after we did that, you know, after they did that, they were asked to just do very basic sketching with these new digital tools. How could it work and what would it look like? So they were asked to kind of create a basic flow diagram, a kind of narrative diagram to track usually something in the range of like, well, we talked a lot about users, you know, what the user might be of that system, whether it be a human user, whether it be a gallon of water, whether it be a, you know, I don't know, you know, 20 pounds of human sludge, you know, or sludge waste, whatever it might be, whatever that user might be, and then to think about how that might move through the system and create a diagrammatical representation of that narrative. And then from that diagrammatical representation, they then began using the machine learning tools to start manipulating the site, such as you see here. We all know CycleGAN and its limitations and its fun. And then to take the new manipulated site and to apply a intelligent agent system to track that user through the new manipulated site, and you know, and then deal with that. It was a little ambitious, you know, to come up with a fully articulated idea for a future of infrastructure system, and manipulate the site in order to represent that change. Then track agents through that system, through that landscape, to see how they might react. But I think it was supposed to be fun. It was supposed to be inventive and strange, and it was supposed to mostly just introduce the concepts of these tools, how they might work, you know, and how you might begin to sketch with them. You know, like not necessarily to create a finished product, but to learn how these tools might inform your thought process and your design process, and also how to use collabs. I think it's probably the real lesson that got passed down through this whole thing.
We also just talked for so long about like what it means to make a data set, like for research versus images. Like, what even does that mean? Like, how do you make that do what you want? Because we spent a lot of time talking about data sets.
Yeah, so baked into all of this, of course, is a bunch of ontological discussions about the nature of the tools we're using, and which is probably the most useful part of the whole thing. But I think some of these projects are really kind of interesting and provocative. And for 9 days, I'm certainly did a better job than I could ever hope to do. So I think we should just jump in with, are we starting with the snails?
I go first. Yeah.
This one's pretty good. So without further ado, Ning, if you'd like to present, we're all ears.
Yep. Okay. So, hello, I'm Ning. And I'm gonna present my project. Share my screen. So, okay, it's here. Or it's just too slow. Okay, so my project is called the Snail Stopper. And if you recently you'll find that there are severe floods happening on both sides of the continent, from Western Europe to Central China. And here my project deals with water, with one of the most common methods, that is to build a dam and its reservoir. And the case I chose to study from is the world's largest dam, the Three Gorges Dam, from Chongqing to Gui. Its reservoir is more than 660 kilometers. However, dam doesn't only stop flooding and make profit, it brings social and economical problems. So you can read the problems it brings from well, before the dam was built and after villages were submerged. And
sorry, I don't mean to interrupt. Why do you mean to interrupt? The internet's doing that thing where it like pauses and then like speeds up super fast.
Yeah,
no worries. It also, maybe you could try to turn off your video because sometimes that helps.
Okay, yeah. Okay. It's okay. Maybe I'm gonna go back to this one. It's still quite. Let me see. Okay, monitor this. I will start at that page again. Because in my screen, I'm not in that you are viewing. Diagram shows you the of the reservoir, the super long 600 kilometers.
Okay, Ning, I have a second idea. Can you hear me? So I think what we should do is, can you upload your presentation and I will run the slides for you? And then while that's happening, maybe we'll have Hyundai go and then we'll go, you can go second, okay? Because I want to make sure we can hear you talk about the snails. I will not be able to do it justice.
Hello, can you hear me now?
I can hear you, but we couldn't really hear you.
I was kicked out of the.
Oh, okay, so
okay.
Can you just upload your presentation and I'm gonna run the slides for you? And then while it's uploading, we'll just have Hyundai go, okay?
I believe it's in the Google Drive.
Okay, give me 1 second then. Okay, can everyone see my screen now?
Yes.
Okay, great. Ning, go for it.
Yeah, thank you, Laura. Thank you. Should I start from the beginning or
I
start
think so.
from
Let's just start fresh
where I stopped?
from the beginning.
Well, okay. Well, thanks for your time and patience. So my project is called the Snail Stopper. So if you read the recent news, okay, that's just a brief intro. But basically, the flooding problem is very severe around the world, and so my project deals with water, and I chose water dam, and its reservoir as the infrastructure that I'm studying. And next one, please. Yeah. So the case I chose is the world's largest dam, the Three Gorges Dam. And next slide, please. Well, so it's from Chongqing to Zigui, and its reservoir is super long, 600 kilometers. However, the dam doesn't only stop flooding and make profits, but also brings social and ecological problems. So for example, towns and villages were submerged and the dwellers were forced to leave. Also, there are some migratory animals lost their homes, especially fishes and crabs. So thus, to find the balance between water control and ecological impact. Well, next slide, please. We may make radical decisions to permanently flood part of the city in order to prevent uncontrollable natural disaster. And this sequence, well, these two images shows the before and after of the Three Gorges Dam, and this scenario will be applied to the site, well, the Seoul site. Next slide, please. Okay, I guess we may jumped one. Yeah. Okay.
Which slide
So,
do you want to go?
And yeah. Sorry.
No, I was just I was unsure of which slide you would like to.
Okay. Great. Thank you. So. Okay, that's the correct one. Yeah, thank you. And this project is to discuss whether or how to apply them to Seoul. And the future scenario will be created with the help from machine learning. So that's a a very natural scenario of Seoul, and then later when the dam was built and the urban part will develop alongside with the construction of the dam. Yeah, it's just that you feel the vibe of that area. And this is well, learned from one of the flooding happened last year. And I'm thinking here, what if this what if the flooding happened in Seoul? Well, a massive dam may change the regional weather condition a lot. And well, also after this series of bird eye view of the future, this project actually focuses more on the view of the very specific individual creatures. So the design and the research starts from examining the key species of that area, the snail. Next slide, please. Hello, could you go to the next slide? Yeah, thank you. So for human, the snail causes snail fever, but for fishes and crabs and other aquatic life, the snail is an important food resource. By controlling the amount of permanent floods, I want to bring animals back and also bring humans back, but also keep the disease, the snail fever, away. So next slide, please. Well, so in this simulation of the movement of the snail, I selected the attractive and repulsive spots. Well, yeah, there will be a video. Could you play it, or you may also copy and paste the site. Okay, here you can see the simulation of the movement of the snail at that site when it's flooding. Yeah, and after figuring out the hotspots for snails, we can thus separate let's say the area that's occupied by the human and those for snails and other wild animals, so that the dam will not only balance the local ecology. And there's a GIF. I'm not sure whether you can open it or not.
Doesn't look like it. Sorry.
Well, I guess that's okay, because that image also shows the like the overview of the dispersion of snail families from their hotspot. So yeah, and the final image is just I was trying to visualize the let's say relationship between the human and the snails, and to try to find the balanced key point. Yeah, and that's it. Thank you.
Sorry for the technical difficulties, but great job. Okay,
Yeah,
Hyundai.
thank you, Lauren. Special thanks to you.
Should I?
Wait, we have one more prep. We'll do groups.
Okay,
So
okay, okay. Oh, I'm so anxious.
Your chance, Pedro, to talk about snails.
Hello, my name is Hyundai, and I studied about wind power. So, wait a minute. So like a few weeks ago, oh, by the way, there is so we call Jeju Island in Korea, and have you heard Jeju Island? Like, it's very famous for Korea and many neighbor countries. A few weeks ago, I traveled the island and I was inspired by this scenery. There were a lot of wind turbines near coastal area of Jeju Island. So yeah, I focus on this renewable energy source. So my statement is that what if Jeju Island went to 100% wind energy? And my projects begin from some disadvantages of wind power. So I mostly focus on this one thing, because renewable energy is so inconsistent they are very dependent on weather condition, you know, and so and especially the speed of wind is very important to wind turbines. So this paradox we called curtailment paradox. So even though we increase like investment in renewable energy source, like they cannot reach proper effectiveness because they are dependent on weather. Yeah. So when energy needs, the Jeju Island usually borrow the energy from the mainland, or they use conventional energy source. Yeah. So because speed of wind energy is very, like speed of wind is very important when it comes to wind energy. So I studied about the data of wind map, and like, you know, like monthly, daily wind direction or speed of wind are changing. So this is my original satellite image of Jeju Island, and then I did cyclogram process, so I got this image. By using cyclogram image, I could imagine like Jeju Island full of wind turbines, and this white or black shadow means wind turbines. So because wind speed is very changeable, so I referenced like mobile wind turbines. Like, what if launch mobile wind turbine to catch like wind energy source, or to find proper area. So basically, by using like GAN image, I draw like imaginary sectional drawing. So like every and this is sectional drawing. So when you travel, if you travel Jeju Island, then there is like coastal load exists coastal load. So by using the coastal load, I add like kinds of platform. So this center one could be used as like hotel or tourism program, and under like under the building, like there is like electrical energy processing unit, and like all of energy from the wind turbines flow into this processing unit, and then like again it sent energy to like urban urban area. So I made like kinds of wind spiders, like which have like quadrupedalism system, and this spider just roam everywhere Jeju Island. And also there is another type, battery spiders, and the battery spiders is subordinated to this LED building, which is main program, and they collect like battery from the wind turbines. And I made some animation. Sorry. So this like each spider like acts as intelligent agents, so they keep minimal distance from each of them, because you know, if the density is too dense, then it will be ineffective. So they keep minimal distance, And also I made another animation. Oh, so like, yeah, this is like actual my imagination 3D external animation. Like, so if they reach like proper size, then like, they stretch their legs because the leg is too long enough to, yeah, they stretch their leg and they anchor to ground. Yeah. Okay, thank you. That's all.
Amazing. Thank you.
That's really come a ways since I saw it 2 days ago.
I wouldn't mind starting. I think both projects are amazing. And I think what's great about both, just on a side note, is that you're not afraid to kind of be clumsy or silly when you're doing this, which I think is really important, because even though these wind spiders that you're talking about might seem funny now, I mean, they could worthwhile be something in the future that could actually help. But I have a few notes for both projects. The first project, Ning Wei, I thought it was very interesting that you were concerned with hydropower, and also at the same time trying to confront the difficulties of hydropower. Hydropower is a great energy resource because it's mostly a passive system, meaning that the majority of the phenomena that is able to provide or allow the dam to make the energy is quite constant. And furthermore, especially with modern tech, the actual running of the facilities is quite low in terms of cost and upkeep and whatnot. So it's a very efficient system. The problem, as you rightly pointed out, is that it's a very devastating system and can completely ravage and destroy ecosystems. Like you mentioned that the Three Gorges Dam, when it was built, displaced people. It displaced something, I think, along the lines of 1.3 million people, some of whom were also in very historic UNESCO World Heritage sites that were also flooded during it. So there's not only a human component to this, but more importantly, dams destroy a lot of species' ability to procreate, because specifically in lakes, most species have patterns or rituals that are embedded within their biology that require them to move up and downstream depending on what part of their life that they are. And so dams also destroy that. But what I want to say is I think that though the technology right now is something that is dangerous, or we have had pretty severe environmental consequences, specifically in the United States, because we've created almost the most dams out of per GDP in the world. But there are ways that you can improve this. And what I think is really important, what you're doing, is you're not separating that non-human component from the rationale of this exploration that you're doing. And in fact, I think it's really prudent and interesting that you're taking the behaviors of snails as a way or indicator in which you can then use as a design tool or a template to move from. And if you're able to do that, not only with snails, but multiple different agents, you can imagine that you're able to simulate scenarios where you could use hydroelectricity power while not necessarily disrupting the ecosystem, though the ecosystem will obviously have to change. So I just want to say, I think it's a great project. And I think the insight of being able to consider a non-human agent and non-human infrastructure, for that matter, as a way to create causality or to create understanding of the site.
I think what he was going to say is it's really cool. It's really great.
Thank you.
Yeah. I don't know.
We lost him pretty
I
hard.
hope he can hear, but
That's probably tricking on your projects. Yeah, well, I mean, I'm happy to sort of jump in after that too, because yeah, I mean, I actually really appreciate that, like, well, okay, the theming of these projects, grouping these together for the presentation is good. This sort of idea of these, like, I mean, I don't know what the rest of the projects are, but this sort of animal versus animalistic study, one literally sort of focused on animal movement, the other one sort of emulating this kind of this movement across these landscapes. And I think just one thing that I really appreciated about the Wind Island one is there's just sort of like, you know, it's like I'm excited for this because I think there's, you know, you have what, like 9 days, and there's so many like layers of detail that you could dive down into this already on. There's just this sort of simply having these two stacks of movements, the sort of the wind turbine itself and the battery spider itself, sort of already creates a level of complexity that, like, my mind just gets really excited about this. And it's not actually, I think, you know, that in a good way, it's not that crazy of an idea. In, you know, in coastal areas, I've heard of sort of energy harvesting through like temperature differential off the coast. You know, you can just get this sort of like osmosis energy gathering through these things stationed off the coast. The only issue with that being they're off somewhere in the ocean. And so you create these things that are floating and bobbing around, and you get these autonomous boats to go around and essentially just like pick up and swap batteries. So there's this sort of idea that like infrastructure becomes a little bit less sedentary and a little bit more mobile. And it's not, you know, and you can pick it to pieces. You could say like, well, how much energy does it take for this like wind turbine to move itself to a place where it can turn itself on, if we're already talking about like, you know, wind power being inadequate. But I like this idea that it's you know, kind of exploiting these areas where the infrastructure might already exist. It's creating different like hierarchies of movement and sort of and time. You know, the wind spiders might move once or 3 times a year, but the battery spiders might be moving on a daily basis. You know, these sort of create these interesting combinations. And, you know, I think the only, like, part of me wishes that in the wind spider project we had seen like drawings like the ones in the snail project. Like, I love those drawings and diagrams. They're just like beautiful to see the overlays and the different kinds of the agents versus these sections and paths. And I feel like seeing that in motion on the wind project would also be incredible. Like to see all these different paces moving on top of each other.
Yeah, I was going to say, first of all, congratulations. These are beautiful projects. And especially pairing these two projects together, I see a huge different way of approaching to, analyzing real life problems. Well, Ming's project is very much of solving it through statistic, simulation. And Hyundai, you're like approaching it using the math, the simulation, and then apply a layer of design on top of it, which is quite interesting. And first of all, Ning, I know, I'm Chinese myself, so I know there's a huge flooding problem in China at the moment, and this snail thing could be really could be a thing. And the simulation of a non-human object moving is just so exciting for some reason. And then I guess it also brings me back when I was studying statistics back in college using this software called MATLAB. And there are a lot of this like simulation happening. At first, you don't really see them as actual data sets because they're just, imaginary parts. But when you have this much research applied to your study already, and these numbers becomes a concrete fact for your project, I think there's some excitement of this. I don't want to say it's a false reality, but it's almost like you have proven this. This could be proven to be real if you are using the correct numbers for simulation. And for Hyundai, Wing Spider is so wacky, and I just love it so much. And it reminds me of the animation I watched when I was little called Eva. There's a bunch of robots landing on the earth, and then they start to spreading. And especially the section you did, I believe those are wing spiders over time. Really beautiful. And I recently saw this image on Instagram that I believe it's American military has been drawing the change of the Mississippi River overlapping on top of each other. They're just like, you see, a similar thing has been changing over time, but mapped on the same map at the same time. There's weird timelessness to this. project, but seeing them moving, it's very like up to date at the same time. Like the sci-fi kind of energy, especially when I see the spiders are walking on the water. Like that's something we definitely needed for future designs. I'm glad Case and Laura introduced this project as speculative design. I think both of the projects are really nailing, to the speculative part, and then just, and this could be a possibility in the future. I'm not doubting it at all. Great job, guys.
I don't know if Tucker wants to go back at some point. Okay.
I'm gonna write it in the chat, so go ahead. Sorry about that.
Okay.
Computer crashed.
Okay. Don't kick your Wi-Fi. I wanna make a point on the combination of these two projects. I think that they are both very different at so many levels, but okay, the first one, I think that you took a resource about how to manage population on cities, human infrastructure as cities, or human infrastructure as these dams, the way that delta rivers already work. Okay, for example, right across where I'm living right now in Rosario, we have this huge delta river, which it keeps control of its landscape by keeping away humans from it by flooding. So it is a very clever thing to do if you want to try to reshape, redesign all that landscape and let nature do it. Okay, so you can keep controlling that flooding by somehow, and you start keep snails right away from that city, and it's a huge operation that you're doing on that landscape, right? You're giving in tons and tons and millions of tons of sediments right inside that what it was, that city, and that's pretty clever. I think that's a huge and a massive landscape operation. And on the other hand, we have the other project that it tries not to manipulate anything of the landscape. So it has these legs that can play around all the island, try to over the island and trying to catch the wind, of course. So that's why my point was about how different are these two projects, which both of them are playing with landscape, but one is very aggressive, like the most aggressive project that probably I ever seen, and the other one is super minimalist in terms of, I don't want to bother humans with this, so I'm gonna put these robots trying to catch the wind whenever the houses are not on the landscape, so I can avoid humans, I can avoid everything, so I don't disturb humans. So what I'm trying to create here is a point of how the citizens will react to one project or the other project with their body, with their everyday life, with the everyday landscape, with the and at the end of the day with that engagement with nature or technology, right? Which is kind of at this point the same, right? So that's kind of it. Great job.
Well, thank you, Pedro. I just want to maybe make a quick reply to your comments, and really thanks for your comments, and that just triggered my thoughts about, because you talked about the reshape of the landscape, and in fact here I was also like the starting point of my project is dealing with like those social data and the people that was impacted by the reshaping of the landscape. Because with the huge dam, although somehow we force the people out and let the nature do its work. Also, it's in some sense quite artificial landscape that we've created. So I was trying to keep a balance between the very natural one that was not disturbed by human and the very massive artificial project. I was trying to find the balance between them. Yeah, thank you very much.
I also have like one final comment. By looking at both the projects, they are very different, but they also have they share like the same approach, the same initial approach, which is very positive to see in these kind of projects that are like kind of speculating towards the future. And the common approach that they have is like to go back, not going back, but like orient your thoughts towards nature and the organic behaviors of animals and our planet in general, which is something that we should always do, but like most of the times when we are thinking about like future speculations and the development of human race, we sometimes forget about that. And it's good to see on one hand the kind of like the kind approach of like listening to nature and trying to include the natural behaviors of other beings that are like inhabiting the planet in our future speculations. And on the other side, observing nature and using natural behaviors of other animals in order to actually read what is the potential of our planet. For example, like the spiders' movements remind me of like swarm intelligence, or like the behavior of flocks when they kind of like follow specific places that are like they're like perfect, ideal for them, and they do it in groups, but they follow specific rules in order to exploit the potential of the natural landscape that the planet offers them. And it's good to see these kind of like reinterpreted from our point of view, because I think that we need to go back to that. Or like if we've never done it, it's time to do it. So great job.
One interesting thing about yes, great job, Ning and Hyundai. Amazing projects, a lot of fun. One funny thing about Hyundai's wind spiders is that originally the project was just traditional wind turbines that had taken over the landscape. And we had this like mid-workshop crit, and he was like, yeah, maybe it could make new tourism. It is kind of like an eyesore. He was definitely worried about this idea of like overpopulating what is supposed to be a tourist destination with all of these wind turbines. And then he decided, well, let's look at wind paths. Okay, let's have wind turbines follow wind paths. Let's make them spiders. I mean, like, it was fun to see the progression and thought process through that, I guess. So, but great job, both of you. But we're gonna move on. So, Ian, are you ready?
I'll start. Hello, I'm Yana Kim, and in our unit, I did some research and proposed an eco-friendly wastewater recycling process in Seoul area. Han River, which is located across the Seoul, accounts for a large portion of Seoul, and it is a very important water source. Seoul has 4 wastewater treatment plants, and it provides clean water to around 10 million of people living in Seoul. It looks like they're working well. The problem is that rate of reusing wastewater is only around 15%, which means 75% of wastewater is discharged to Han River. And in the end, the algae bloom was occurred and it badly affected the water quality of Han River. And also wastewater treatment plants in Seoul are based on mechanical process consuming lots of steel and electricity, which is not eco-friendly. With this problem, I started to think that what if Han River itself is used to treat wastewater without any machine, but just water? So I did some research and found that when water treatment plant in Melbourne is treating sewage based on water and bacteria decomposing organic materials in sewage. With the idea of water-based sewage treating process, I proposed eco-friendly facilities in Han River. First of all, Riverside is covered with concrete right now, and this has destroyed ecosystems and water quality. So concrete is needed to be changed into natural wetland. Also, I proposed watershed cleaning wastewater with bacteria. This is a simple diagram showing how the watershed works with wastewater. When wastewater inflows in the watershed, it starts to move around and meet bacteria. Then bacteria break down and digest organic materials in the wastewater. And also by being provided air with aerators on the surface of water, bacteria and aerobic layer help decomposition, and on the bottom of water, bacteria and anaerobic layer did. And this is entire wastewater recycling process, including the watersheds. When wastewater is sent to the water treatment from apartment complexes, water passed through the watersheds and the organic materials in water are decomposed. To make sure that water is treated well, water goes to the nitrogen removing plant and disinfection plant. And water is disinfected at the final stage. It will be discharged to the reservoir and sent back to the apartment complexes. When water is sent, heat and cooling energy can be transferred to the apartments by water, which is called hydrothermal energy. And the yellow one shows how sludge, which is a byproduct of sewage treating process, is treated and recycled to biosolid for renewable biogas energy in treatment plants. And this is my site area, and there is not any water treatment plants. So I wanted to figure out the location of watershed through Cyclogen. And for that, I chose these two images. Left one is water city in Africa, and I thought the green leaves on the ocean can create wetland and Han rivers. And also right one is natural wetland in UK, and I thought it can also create watershed and a couple of wetland area in Han River as well. And this is a result from Cyclogen. As you can see, some wetland shape was made in the Han River. And in this one, you can see some water flow and watershed area in Han River as well. So I combined these two images, and this is the final image. There are some data such as location of apartment complexes and drainage data. To create a new drainage system connecting apartments and river, I used data of manhole because I thought manhole is located on the top of the water pipes, which are under the ground. And I thought if I can find the locations of manhole, then I can find the drainage ways. So I used numbers of manholes in each district and daily sewage amount per person and per district to figure out how big the size of waterworks should be, because it decides the maximum distance of manhole in the city. This is based on the law applied in Korea, actually. So in this image, all the data I used was embedded. And this is not exactly my site area, but including part of my area. And I wanted to put this because I like this so much. And thank you for listening.
Great work, thank you. Yeah, you're gonna go next. We're gonna learn about a piece of infrastructure that I did not know existed, which might be one of my new favorites, a different kind of dam. Luya, are you ready?
Yes.
Okay, great.
Hi, I'm Woo Choi. Let's start the presentation about Borough Dam. You may know that the Han River overflowed last year. The two portals of the Han River Park in front of Olympic Road, and you can see being submerged. This is not the first time the Han River has flooded. It's been 9 years since such a major flood has occurred, but oftentimes heavy rains broke roads. I'm interested in solving these problems. The graph on left shows the average rainfall. In Korea, rainfall is regionally and seasonally best. So floods and droughts are frequent. Dams are needed because about 65% of the country is mountainous and has unfavorable natural conditions for water resource management. Integrated water resources management is being implemented by K-Water. Integrated water management refers to the integrated and intelligent management of water quantity, water quality, aquatic ecology, and environment, which were managed individually in consideration of everything that affects water management in the region in order to manage water optimally. Let's take a look at the existing dam. Dams have expected effects and problems. The expected effects are securing water resource, flood reduction, power generation, and the problem is ecosystem destruction, disruption of river continuity, and green energy. Morning Glory Spillway at Lake Berryessa near Napa Valley, California. The spillway is 22 meters in diameter and the Monticello Dam is 93 meters high. It has the advantage that it can be applied when there is a space constraint in the installation of a freeway or when it is difficult to install another type of freeway due to topography and geology. It can suck up water without mechanical devices. This is the Fukujato underground dam in Okinawa, Japan. An underground dam is a facility that blocks the flow of groundwater by installing a water barrier in the ground, causing water to accumulate in the aquifer and pumping up in the ground in the aquifer containing water. In order to prevent flooding of the Han River, I found the bridge that flows the most. The bridge was a Jamsu Bridge. It was built in 1976, but has been rocked every year for the past 45 years except 5 years. When the water level of the Han River exceeds 6.5 meters, the bridge is flooded. To reach this level, 7,000 tons of water per second must be continuously discharged for 7 to 8 hours. If this is 5.5 meters, pedestrians and bicycles are restricted, and if it is exceeds 6.2 meters, vehicle traffic is restricted. This is a technical diagram using Morning Glory Spillway and underground dam described above. When a flood begins, the overflowing water is sucked up to the Morning Glory Spillway. The force of the falling water causes hydroelectric power plant to operate. Water is also stored in the aquifer. The hydroelectric power plant then generates electricity and pumps water from the aquifer for use. It is sent to each home and factory to the substation and circulated. In this way, through the process of the beginning and the flooding, it is possible to reuse water and obtain energy at the same time. In order to decide on the design, we tried to minimize the problems with the dam, such as damaging the continuity of the river or destroying the ecosystem. Rather than making one large hole to suck in a large amount of water, I wanted to have several, and I want to set the level of each hole to absorb water properly according to the size of the float. In addition, the ground level of the hole is made into a park so that the Han River Park can be created continuously. And when there is no float, it is intended to play the role of a citizen's park. And furthermore, the cross-section is not only planned as a passage, but a water management facility or an estuary facility of a power plant is planned. I tried the cyclogen test to apply the desired city image to the original city. In order to machine learning the design of the park with the water sucking hole when the flood occurred, I found the picture of the park in the shape of a circle and a picture I found a picture of the park in the shape of circle and a picture covered with water. The picture on the right is a picture of the cyclogen test. It is not a perfect circle in the middle of the city, but a park was created in the middle, and in particular, you can see that there is a lot of greenery on Han River. I would like to see how this system is applied with a photo of the Han River, including the Jamsu Bridge. First, though the image is simpler, the relationship between the river and the city was divided by the size of the circle. Then the location of the borough dam was determined. By applying the location of the borough dam to the attract point, we created a grid where the system is applied to the city. Using the shortest walk, I made a grid that the system is effectively applied to the city. To the soil vector, it can be seen that the river flows naturally downstream even with a borough dam. There is a vortex shape around the borough dam. It means the borough dam can do its job properly. I made a simulation via cupola. If it is supposed to rain, it will like this. Rain will flow to lower levels and flow into the Han River. As the water level of the Han River rises, water will flow into the borough dams. Finally, you can see how water collects and stores in the borough dams. Thank you.
Great work. Thank you. And then we have one more project in this group. So Gil, are you ready? And can you share?
Okay. I focus on the infrastructure problem in Seoul. Currently, the landfill in the Seoul metropolitan area is located in Incheon City. However, as Incheon City declared that it could not accept waste from the metropolitan area from 2025, Seoul City faced the problem of finding new landfill. The diagram shows the waste disposal process. The diagram shows that no matter what the process is, waste needs to be buried in the most cases. Therefore, landfills are essential. Seoul metropolitan government has held a landfill selection contest twice, but local government do not want to accept the city's coverage. So landfill is a problem that needs to be solved in Seoul. However, the Seoul city land price continue to rise and it's hard to find the site for landfill. So I thought of making an island with landfill in the Hangang River and using it. However, if the island continues to build it, the Hangang River will be full of island. Therefore, it seeks to create sustainable, reusable landfill. this is how sustainable landfill process work. And it takes 20 years for stabilization. And these 3 landfills is used alternatively. Landfill do not cover waste during the stabilization period, while one landfill is in period of stabilization, another landfill covers the waste. In this way, several landfill can be used alternately. We cannot suddenly create an island. It needs soil or ash from incineration. So the landfill would be better located nearby incineration facilities. I decided site near Nanjido, which was previously used as a landfill. Now it is used as a park. Develop Nanjido as a sustainable landfill. I used this image to make island in the Hangang River on the left image. So result came out like the left image and combined result and original image. And to make an island look like an artificial island, I ran cyclogen one more. These are the results. Through cyclogen image, I was able to predict how the island would be formed and visualize how landfill will actually work. I tried to use the image to show the construction process of the island, and I will visualize how the land is used over time. By 2025, some of the landfill used in the past will be excavated and developed as a sustainable landfill. At the same time, the first island is constructed with soil and ash from burned garbage from the excavation. The second island is constructed during the development of landfill used in the past, such as previous one. In the meantime, the first island began to operate as a landfill. Then 20 years later, the second island comes into operation as a landfill, while the first island has a stabilization period. This part of the landfill used in the past is used as a landfill now, and the second island has a stabilization period. And the first island has a process of disposal stabilized waste. And now this part operates as a landfill, and this part has a stabilization period. And from now on, landfill divided in 4 sections will be used alternatively every 20 years. And I visualize the minimum distance from the garbage around the site to the landfill with the grid. And it's a trash movement I expect. And this is visualization of the facility related to waste disposal and the scope of the facility impact. And it's trash movement of Seoul City. It's going to waste disposal facilities and heading to landfill. Thank you.
Amazing. Great work, you three.
I guess I can start. So for the first project, I guess transportation is always an ongoing topic in a city scale design. So building a pipe system to direct different wastewater to the wetland would be really challenging. So it's really pleasant to see you're actually including the building locations in the trained wetland image, which are within the consideration of the transportation topic. So if we're not talking about destroying the city and reconstructing it, it will be very interesting to see some zoning changes on the existing facilities based on the distance from the different facility to the wetland. Maybe different type of different part of the wetland is treating with different water. That'd be really interesting to see. So for the second project, well, also designing a city scale will be to that project could be literally considered as choosing a right and successful model and just simply plant them to the needed location. There's this really unapologetic attitude toward this project. For the matter of fact, and the simulation actually shows how the dam is collecting information, is working through the collected information, and somehow just prove how successful this workflow is, which is quite surprising. I never really thought about like taking the existing model and then plan it to the needed part is such a power move. And as for the last project, the image of how to construct this land over time is very intriguing. So it makes me start to think about what if you are taking segments of the map and train them separately? Does the time of the training of each image actually means anything? Maybe the slower it gets, they get trained, the longer the construction may be. I don't know, like there's some interesting thoughts when you are trying to include the time factor into a training process. And then overall, very great and amazing, especially seeing the piped image, and like a lot of simulations are actually proven that your thoughts can be actually constructed and solving problems. Thank you.
Yeah, these are really amazing projects, guys. And I think, one of so, okay, taking one brief step back, like I think these are kind of exciting because like taking LA, where I'm currently located, as a good example, like we've been undergoing this big transformation for about the past 40 years where everything was built initially in a very segregated way. I mean, segregated in a lot of different meanings of the word, but we could say like segregated by use. There was an industrial area, there was a suburban area, there was a sort of a city area. And it sort of seemed like the old version of a city where you find places for things and those things are there. And it's sort of, we're now under this huge rebuilding process of trying to make everything be zoned in a way that's more mixed use, and it needs to function on a sort of a smaller scale. You can't have a 12 million person county and still have there be a suburban area. It just doesn't work. And what I love about these projects is it's sort of applying that mixing to all these things that we normally try to expel from the city, whether it's sewage or flooding or trash, and this idea that like we can instead exploit the existing either infrastructure or shape or simply terrain of the city and reframe, welcome all those horrible things back into our city. And it's obviously it's not like total fantasy. Also in LA, one of our central parks, Griffith Park, a lot of people don't realize that it's a landfill, or it was a landfill until about 25 years ago. And it's in the middle of its recycling period, being turned back into sort of grassy mountains. And there's a sort of sense that that's like, out of fashion to sort of have a landfill in the middle of the city. But I love that there's this sort of this argument that it's like, rather than fighting to resist these kind of these things that are normally treated as problems, like, can we simply just, utilize the flooding? Can we let waste treatment happen everywhere where we normally just gave access to these tubes that would expel the waste? Can we sort of integrate the city and reframe how we think about these processes? So I there's a lot about the specific projects that I could geek out about. I love the visualizations and all of these, but just overall, like I think I really appreciate the way you guys have been approaching using this urban project and using the tools of the workshop to kind of ask those questions of the city.
I'll briefly jump in. I think all of these are quite extraordinary given that this was only 9 days. Any of the critiques that I'm giving are not because you haven't done anything, it's because you all have provided so much insight and output and deliverables that we can have a pretty robust discussion. So I think what's great about pairing all these 3 projects together is the fact that they all deal with water, which is becoming more and more apparent outside of, say, global warming and CO2 emissions. Obviously, water behavior and all the water rights that we're going to have to deal with in the future have to do with global warming, et cetera. But more than the earth heating, we're going to have to deal with these constant embattlements of water trying to breach our cities, destroying things that we have tried to preserve and build. And the majority of the reason that is because we have created robust, hard infrastructural networks throughout our cities, which are not able to change with time and are not able to really respond to the amplification that we're experiencing with these calamities. So what I would suggest with all these is, and what I like about the first one, perhaps I'll go one by one and really quickly just give some insight. In the first project, what I love is that you're using filtration ponds. And what I would say is because you're also coupling that using CycleGAN in the beginning, the beauty of CycleGAN and other style transfer or paired networks, machine learning networks, is that you can couple information with aesthetics and imagery. And what I would say is that filtration ponds, like if you look at the salt ponds, for instance, in the Bay Area in San Francisco, there's an amazing and almost surreal aesthetic quality to the ponds, specifically with saltwater ponds, because they turn red and orange and all these really beautiful colors. And I'm wondering, because you're using CycleGAN as a tool, that instead of having a very ambiguous attitude towards what you're filtering, is you become very specific about exactly what each pond is trying to filter. And what will emerge and come out of that is each pond will have very specific behaviors, very specific aesthetics. And because you're using machine learning, I think it's like a perfect pairing of that. So that's what I would recommend. With the second one, I think it's a genius to look at burrow dams as a flood preventative measure. This is something that Tokyo is looking into. Not sure if you, in your research, were able to look at the huge flood prevention network in Kusabe right outside of Tokyo, but they're essentially building huge caverns underneath the city to be able to capture rainwater. And what I'm wondering is that you've done a very similar thing, but what I would ask is maybe there could be ways that you find you've done a great job of sort of articulating the agent behavior. I wonder if it would be possible that that can start informing the actual design of these cauldrons. Like, you don't need to necessarily take the burrow dam as it exists now as a example of how to do it. You could formally, using all the information that you've obtained, create very new, interesting forms like they have in Tokyo. And then last but not least, I think it's brilliant that you're looking at landfill sites. And what I would say too is that islands, I mentioned this in my comment to Hyundai, islands have actually a huge impact on local ecosystems and biomes. And what I would suggest is that maybe you could use this as a way to also impact local wind patterns and rain patterns. And if you're able to get enough or large enough of islands with enough height, you can actually begin to really control and synthesize an environment which is hospitable for what have you, whether it's grain growing, herding, et cetera, et cetera. So great projects. I think they all are like perfect beginning parts. And what I would, or points, and what I would recommend is now using that, figure a way that you can couple the tech that you're using and push them even further, because they're wonderful insights. And I think they could turn into something really great. So great work.
One thing I also, oh, you go, Pedro.
No. I was asking Raquel if she wants to go, since she got the last comment on the previous one. I go?
It's all you.
Okay.
Oh, yeah.
You want to go at last? Okay.
Yeah,
Don't
No,
worry.
no, it's not. I have one quick comment. I can say it right now.
You can go.
That I'm thinking, especially for the first, like it's surprising how in 9 days you can get all of these information about all of these different systems, and it's every work is great, because it's like the most important thing here is like what are we aiming for, like for our future, and it's the right approach, right, like in every single work. But especially the last project reminded me the importance of considering time and phasing, because these are all things that like could be taken seriously, and it's right to just like for example, considering the time of stabilization and formation, and how could this project could be actually implemented over time. So it's an element that should be considered always, especially if you believe in what you're researching and developing. So that's it.
Sorry, I don't want to interrupt anyone, but maybe like I want to have one sort of specific response to that as well, which is like I think it is really true that like the one very seductive part of style GANs is that it's wholesale and immediate, and and that runs in great contrast to the fact that so many of these things either would be happening at a very incredible scale, or Gil, like in your example, you're phasing this in a very deliberate way. And so I mean, I think even just like Nero starting to ask the question about like, could you operate on each tile differently, and all these, like, I think all of these, it seems like all of these questions do sort of come around that, like the agent tools, especially that you're given, is a time-based tool. And I think there's just something like it's very exciting when these projects like latch on to that time-based aspect of it, and sort of it brings a level, as you're saying, Raquel, it brings a level of like reality to it that I think can really make the projects click. So I mean, great work again.
Yeah, because I think, I think we talked about it in workshop, but like Hyuk's project, its temporal boundary could be somewhere from like 1 to 24 hours. Gil's is, 60 years. Like each one of them is operating based on the user, is operating in a very specific like temporal boundary that kind of is one of the constraints of like the design process that we tried to give them, was like, how long, what is the timeline? I think we showed a lot of timelines as well. What is the timeline of this, like how, of the user's interaction with the system or the development of the system, like in Gil's case?
Nero, you want to go first?
I'm so sorry. I was just making fun of Ricardo. Last comment.
Shut up. Okay. Okay, my comment is super silly, but I can see these 3 projects super combined. Like you could do just one project, right? You just take out the water from street, you put it on the rooftop, where you're gonna have these purifiers. I don't know if that's was the word, but at the same time, you are trying to avoid the water to touch the the landfill, because it's kind of full of waste. So you have to avoid the water getting in touch with the landfill so much time, and then you just pump the water right super fast to the rooftop, where you can storage land and being purified. So I can see that these like these different kind of time lapse. I don't know the word you just used, case. Can you?
I use the phrase temporal boundary.
Yeah,
yeah.
You can break those by putting all these projects together. And I don't see like the use of CycleGAN so strong here, which it's okay. I don't mind that hard, but probably in the Yana project, if she could emulate these poles on the rooftop, and then try to connect a huge network in between those rooftops, which are giving collecting water from these super big holes that Yuk is doing it, that could be something super powerful. And I don't know, I'm just trying to make the point that probably because they're all connected to water and they have these temporary boundaries. And again, I lost the phrase, but it could be super cool or super necessary for these nowadays problems in cities, right? Like we need to start thinking about new landscapes where we have to face the consequences to live in between systems that help us live as similar as we are living right now, right? So that is something that we are facing right now. That is something that we need to create a new conscious about it, and trying to think about how we as citizens start to change our mind about it, right? So we can start to accept new ways of or new ways to solve problems that probably politicians, engineers, architects, everybody have to face in the future, right? So because we are the next generation, we already are, right? Because probably most of us are gonna occupy super big chairs at super huge places where we need to make decisions, and we need to be creative about it. We are not just solving problems, we are designing landscape, we are designing behaviors, we're designing new places to live. So that's why I see all these projects that could get combined, because they came from the almost the same problem, right? So because we need to figure out some collective solutions for collective things that we as humans, we're messing it up in the world. Probably you need to talk in between you to solve some of these problems, right? Just that.
No, I
Great
think
work.
we had definitely, or Case and I have talked about what it would be like to overlay all of these projects on top of each other and then see how they might interact, because like there are so many combinations between them, and even the projects that don't necessarily have a direct connection, like you could see how they would work together, or at least could be interesting to think about. So you know, if we had another 9 days, I would love to do that. Or, you know,
Ask for them.
yeah, I mean, I might, we'll see, but
okay, we need 9 more days with these
Yeah, everybody
students.
get back here tomorrow.
We need to.
Well, I mean, I think Pedro, you just hit on the reason we called the workshop the island and the grid, right? Like the mic, is it that's the whole point. Like, do these things exist on their own in isolation? Are they connected? Are they assessed? Is it about a system of is it about nested systems sitting inside a larger one? Like all those different touch points, like that's kind of the whole thing. Like, is it an island or is it a grid? Does it communicate or doesn't it? Like, it depends on how you look at it, what your political, that's sort of in a lot of ways the political question that is like hiding at the base of all of this is, what kind of political, that's why it starts with a speculation and kind of what if question, right? Like, what if we decided that this was something we wanted to do? How much trouble would that actually make for us in the long run? Is like really the question of the workshop. How hard, not how feasible, but this is, but how infeasible is actually any of it? That's a whole nother ball.
I really appreciate that you just bring that up. That was one of the questions that was behind the workshop, and I really appreciate the commitment with, okay, we are speculating, but at some point we are dealing with real things, right? What if we have to bring this solution to the city tomorrow, right? It just have a meeting with the council and just make a presentation. Okay, this is our idea. Like you said before, how many people are we gonna get in trouble if we execute this? How many people would live uncomfortable with all these solutions? Or how we change the landscape? And when I'm speaking about landscape, I'm not just speaking about or urban landscape or natural landscape. I'm talking about landscape or imaginary landscape or virtual landscape or social landscape, you know, how social network, not in the Facebook way, right? But social network really works with all this, right? How you engage people with problem solving, and which is kind of it's kind of the idea, right? I think that we need to create new connections with new landscapes. People is really apart from each other right now. That's kind of the main problem, not water and all that. So I'm not trying to take out the water problem out of it, but I'm trying to say we can also treat water as a way to reconnect people and try to stand for some kind of responsibility on the society, and just that.
Yeah, man, water is a big problem.
Oh yeah, it is. It is, but water, what is that? Okay.
But even though, like, there's a side of me, I know this isn't really how these agents work, but there's a side of me where it's like, what a great workshop if for 8 days you work on these projects alone, but then you all have to put your agents into the same grid, and they all just, you know, horribly undermine each other, and then some of them resonate and then some of them don't. Like, I think there's like, you could even just talk about, okay, so one of the big sticking points for me, or not sticking points, one of the things that sort of like actually makes me so interested in anything that's happening on the scale of landscapes is like the folly of making like an 80-year plan or an 100-year plan, and just like the hilarity of like what that even means when like the infrastructure supporting it won't last that long, when the people in charge won't last that long. So there is something, you know, not to get wishy-washy, there's something about like somehow instead focusing on like what are these systems how are they either resonating, are they consonant, are they dissonant, like what seems to be supporting other things, what doesn't. Like there's sort of that level of collaboration which kind of lasts longer than any specific plan about any specific treatment or something.
Yeah, I think that's why we didn't. That's why it's you know, like at some point the thought experiment is really that, you know. I remember you did a project on deep time, so I figured you'd
yeah
have something to say about that. Yeah.
80 years, come on, let's go 10,000, way better.
Nothing, man. That's like, yeah, you might actually live to see that.
Do we have any final comments? I think that's a solid one to end on anyways, so that's fine.
Yeah, just that water is important.
Thank you for the final comment, Pedro.
Come on.
Well, like also I feel like every day I'd wake up and look at the news and there was some other insane climate disaster happening that was related to someone's project. So I was like constantly adding it to the Google chat of like, have you seen this flooding? Like, have you seen this? You know, so. Okay, so we're on to our final group of 3. Sup, are you ready?
Yes, I'm ready.
Okay, great.
Okay, I'll share my screen now. Is my screen okay?
Yes.
Yes. My name is Jang Min-seok, and I want to talk about the SMR defense and evacuation when these incidents happen. So, according to the master plan of resource for future energy, our Korea is shutting down some of the nuclear power plant, and they will not use the core energy for the future energy. So I thought that what if we use all of the energy deficiency and supply them with the SMR, which is small nuclear reactor. So what if? So using the SMR, we can have the various strength. For example, this is most cheap energy from now gone, and it's eco-friendly so that we don't really emit the greenhouse gases. But there's a lot of threat of the nuclear reactors. First one is the flood, and second is the radiation emission accident. And actually, they use like ton of water supply. For example, they use like 40,000 tons per day. So to use the SMR in Seoul, we should plan the Seoul again. So And for the defense, there could be an accident that some bad guy comes to the SMR and breaks down whole reactors. So we should need the defense system. So what I thought was the traditional village. So this kind of structure can like make the defense point efficiency. For example, to defense whole village, the people should just defense the entrance. So I picked the similar structure from the Burundi city, and I trained this for the site with game study. So it became something like a great cluster of grid. So from this shape, I got an idea of how to respond to the instance. On the left is the how people should act when the flood happens. They should quickly run far away from the river, and on the left side is the incidents when the leakage happened. The population, which is the green, should relocate them outside the dangerous zone. So, and for the water supply, I trained the site with the Venice this for the water supply. So this is the result. And from the GAN study I've got, I tried to extract the information from there. So this is the population information from the Burundi city. And this is the river plan for learning from the Venice. And this is the road plan learning from the Burundi city. But what I thought is that I could improve this road plan to maximize the speed of evacuation. So using the proper geographical property of Voronoi, or in case the multiple incidents happen in multiple SMR, they could run to the segment of the Voronoi so that they could get maximum distance from the instance. So this is the new road plan came from the concept of Voronoi. And to improve more, I think I could this is the initial plan, but to maximize the optimize the capacity of the road, I added the population index and draw it with the line weight so that where there's a lot of population, we could set the width of the road much more wide. So, and this is the final plan for the road. So all overlapping all of the river plan and the road. So this is the master plan of the solar. So I want to show the simulation I did. This kind of guideline how to evacuate. So each purple point is where the population is in. So they're trying to follow the path and get outside of this distance. So most of the people get out, but I'm sorry for these people. I set this dead end, so sorry. So this is end of my project. Thank you.
What a way to end a presentation. 10 out of 10 for style.
It was really good. That's some speculative realism right there. I appreciate it.
Amazing. Okay, Dal, are you ready?
Yeah, I will share my screen. Okay. Great to see you all. My name is Taehyun Park. I will start my presentation. Unit 3's topic is to study infrastructure system in the future city by combining narratives of future city with current data. My interest in the future city is energy. What is the energy for the future city? For the future, we need carbon-free energy. Although the production of eco-friendly energy is increasing, it is not enough to meet the demand for electricity. The carbon-free energy production method I researched is SMR. SMR is small modular reactor. It is carbon-free, efficient, low initial construction cost, relatively fast construction, safe and small in volume. In addition, when it is built in the city, it can work as CHP, combined heat and energy. It is possible to recycle many of the heat that is left after electricity generation. As you can see in this technical diagram, SMR in the city can function in three main ways. The first is electricity energy generation, and the second is heat storage for local heating and cooling. And the last is process heat for chemical synthesis and desalination. City can benefit a lot from SMR, which can, city can benefit a lot from SMR, which can be used again to buy nuclear fuel, dispose of nuclear waste, or build another SMR. Therefore, my suggestion is that Seoul metropolitan government should decide to use SMR for all its future energy needs. How will the city change accordingly? The Seoul metropolitan government will have to change its infrastructure radically. To be specific, the current energy supply structure in Seoul is form of receiving electricity generated by power plants from substations and supplying them to city. Especially the most of energy is supplied outside of Seoul. However, when SMR is introduced, the bottom image, energy can be produced within the city and supplied efficiently. Based on the energy demand on the site in 2019 and forecasting power demand by 2034, we found that our site needs about 7 SMR of 100 megawatts output to supply all the energy in the city with stability. So what is the shape of the city with SMR in it? I think it looks like this. This is my reference image. I use machine learning to find the future of city of Seoul with SMR. There is some software problem. I will show you. This is my machine learning data set. I tried a lot of time. And I finally got these images. It's a result of my machine learning process. Finally, I changed my original site image with the bottom two data sets. I can get this image. There is some bright point for the SMR silo. Based on this image, an intelligence agency, I create three types of urban infrastructure information. The first was the basic urban grid, and the second was the extraction of urban areas, excluding rivers, mountains, and roads. And lastly, the location of plants and the location where electricity would reach. Finally, I combined this data to draw a concept infrastructure network of SMR project on this site. This is my final image. Thank you for listening to my presentation. I really appreciate it. Thank you very much.
Great work, Dal. And now we're going to have our final presentation. Park, are you ready?
Yep, I'll share my screen.
Okay, great.
Hi, I'm Park Jong-wook, and I'm going to talk about infrastructure system related to waste for this presentation. First of all, the reason I came up with infrastructure related to waste is because after COVID-19, the overall amount of waste increased dramatically. So I thought it would be cool to start with infrastructure about waste. And of this infrastructure, I focus more on MRF, which stands for Material Recovery Facility. MRF is the facility that sorts all the waste into different categories like cardboard, paper, glass, metal, and plastics. What I felt interesting about this facility, especially in case of Korea, is that Korea is one of the few countries in the world that waste plastic the most. But people don't seem to take it seriously, as they think that plastic can all be recycled. The thing is, according to Greenpeace, only about 20% of the plastics are recycled indeed. So what I came up with after I read all this information is upcycling. That is to upcycle the recycled plastics into reusable packagings like here, and replace the disposable packagings to these reusable ones. To talk about the process diagram of recycling, before, the process of recycling was done in linear process. And this raises question about, then what should we do to make this process circular? My answer for this is upcycling. The diagram on the right side suggests new process of recycling by doing upcycling. First, food is delivered to the houses using disposable packagings. Then these packagings are disposed after people finish eating and go to MRF to be recycled. From here, about 20% of plastics are recycled and the other 80% goes to the landfill or incineration to be disposed. Then these recycled plastics get upcycled to reusable packagings. These reusable packagings go to the restaurants, and the restaurants start using them instead of the disposable packagings. And here is where the circular progress without waste is made. Food delivered with reusable packagings are never disposed as they go to the wash stations to be reused after they are washed. And they again go to the restaurants and start to be reused again, To talk more specifically about the process of reusable packagings associated with food delivery application, after reusable packagings are made from MRF, they first go to the wash stations before they reach the restaurants. Then the drivers deliver the washed packagings to the restaurants, and the restaurants use these packagings to deliver food. And after people finish eating their delivered food, here's where the food delivery application is used. People press the recycle icon at the main page and notify the drivers that they have finished eating and that they can retrieve the used packagings. Then the drivers take these packagings to the wash stations, and the washed packagings are again returned to the restaurants to be reused. Here. Yeah. To talk about the data I collected regarding waste and delivery, I first cropped the original site area as the maximum deliverable range is 5 km. Then I collected the total amount of disposed waste in each district of my site, and also the number of delivery orders made in each district. And from this data, I roughly allocated the number of MRF and the wash stations in each district. Before I move on to talk about how these allocated infrastructures work, I'll talk about the cyclogen images I got. First, this image is made by training the image of FAST in Morocco to machine learning. The reason I chose FAST is because I wanted to have backend spaces in the middle of the city to use them for wash stations and MRFs. Especially since wash stations should be really close to restaurants, I thought of making spaces of these wash stations in the middle of the city. In fact, most of the buildings have courtyards, and I thought these images may help making backend spaces in the original site. The second image is made by making the machine learning to study the image of Rome. And since Rome has many plazas in their old towns, and I thought this may work too. Lastly, an image of Hong Kong is learned to see how infrastructure is associated with the traffic. So here, these images show the density of infrastructure in the city. The left image shows the density of wash stations in the city, and the right image shows the density of restaurants in the city. Then I ran the algorithm of Grasshopper to see how each infrastructure worked with the other. These lines show how they are connected, and these grids are made from this line. So the left image shows the relationship between the MRF and the wash stations, and the right image shows the relationship between the restaurants and the wash stations. Lastly, I got the black and white image of the cyclogen image which was about using the image of Hong Kong, and I extracted the information of traffic from this image. Then I associated them with restaurants, as traffic is important for restaurants when it comes to the delivery. So on the right side, this image is made from using Grasshopper at Collabora, and the red lines here, they show the path of the drivers that deliver food. And for the last part of my presentation, I made one video. Could you guys all see the screen for the video? The black image?
Yep.
So the purple dots, they are the driver side dots, and they move around the city. And these yellow circles are the restaurants. And thank you for listening my presentation.
Amazing. Really great work, you guys.
I don't mind starting so I can just get it out of the way. I think these are all amazing, and I'm pretty, again, blown away at the amount of work and quantity that everybody was able to work at. It's really impressive. Just because the last project had something to do with waste, and there was another project in a previous group that had to do with waste. If you're interested in engaging with a more theoretical understanding of waste, I would really recommend this book. Essentially, this book traces the history or concept of waste within society and civilization, from Western civilization and outside of it, to really parse through the troublesome relationship that we have specifically in capitalist countries with waste, in that if there is no waste, there is perceived to be no productivity being done. And what I think is interesting about this project is you're finding ways in which, in fact, the least amount of waste actually represents the most amount of productivity, because you're reusing things, which is amazing. So there's that. The other thing that I wanted to mention is another book that might help everybody, by Bruno Latour, called Facing Guy. I put it in the chat. And I bring that up because in that book, there's a quote, which I will quote right now: "The difficulty lies in the very expression relation to the world, which presupposes two sorts of domains, that of nature and that of culture. Domains that are once distinct are impossible to separate completely." And what he means by that quote is that we have this very odd relationship to what we call nature, as this weird entity outside of our control, when in reality, a lot of our sensoriums are embedded so deeply within this concept of nature that it is really difficult to separate the two. And the majority of the infrastructural and intellectual works that we have pursued over the last 2 millennia have kind of rested on this idea that there is a clear and distinct definition between what you can consider culture and what you can consider nature. One of the examples that you could use is, I think in contemporary thought, we're thought to be the ones that are destroying the environment when other organisms also do similar ways of destroying the environment, such as beavers, who create dams, and this pairs with some of the other projects that were discussed, who create dams and at times can actually destroy environments. What's interesting though, is that there's a really complex societal and cultural mainframe that beavers have, not only with one another, but also in an interesting way, they also provide a really good breeding ground for bugs that actually harvest or that like to feed off of trees, which then makes it easier for the beaver to chop them down. And so you have this really weird, in a completely different species to the non-human species, has a really weird sort of cultural apparatus in the production of their kind of infrastructure and other organisms that act in it. And I'm bringing that up solely because what I think is interesting in all these projects and why I really think that snail project is genius is if you can start to trace or understand how non-human agents are acting in conjunction with how we're acting, we might actually be able to come to infrastructure that not only helps us, but also helps non-us, for instance. And furthermore, we can as architects, because we engage with this weird conjunction of both culture and nature and whatnot, we have that kind of vocabulary and capacity to actually do that. So I just want to bring that up as an interesting side note that I've noticed throughout all of the other projects that I think is a nice summary for the ambitions and where you could potentially go if you think in that sort of concept of breaking down what we conservatively think of as nature and not nature. So congratulations to everybody, great work, and you all should be very proud.
Something I just wanted to say quickly was in the beginning when we were giving some ideas of what these infrastructure systems might be, like at a very base level. You can pick nuclear if you want, you can pick waste, whatever. We were nervous about people picking the same infrastructure and seeing what would happen. And I loved the fact that Sup and Dell both picked SMRs and then ran with it in completely opposite directions, to the point where like they could also become one project because they're analyzing it from just different sides, which is just fun.
I thought, yeah, that struck me. Seeing those back to back was in some ways, it was delightful in the sense that it's like, it's the power of narrative. And I forget whether it was Dahl or some who sort of talked about, I can't remember which project it was that sort of talked about it as a narrative, but it's like, one of them is like, nuclear as risk management and risk, urbanism as risk avoidance and risk management. And the other is like urbanism as like optimization of efficiency. And it's sort of like, you almost don't know which city you'd want to live in more or less. Like, do you want to live in the city that's built entirely around surviving, or as we discovered, potentially not surviving, but mostly surviving? Or do you want to live in the city that's built around ignoring well, not ignoring, but maybe like focusing on life as it is, and then you just maybe have less of a chance to survive. So it's interesting that there's, both those, the narratives make them feel like such independent projects, but they both kind of depend on each other somewhat to kind of create a full vision of the city. I think this one of the comments may be a little bit sillier, but it's like, Park, I loved your presentation. I thought just the way you pasted in the diagrams you drew, you have a really strong sense of creating sort of a narrative for the whole process and kind of creating diagrams for it. And one sort of silly thought is running through it is like, I don't know how universal it is, but like, the classic milkman of the US and probably other places too, but at least in the US, the old system was that, the farmers would send out their milk in glass bottles and then deliver them to your home. And then when you're finished with them, you would put the glass bottles at your door. So the next time the farmer came around with fresh milk, they would just pick up the glass bottles and go. And I was trying to think, like, it's the system you're describing, and there's sort of this question of like, well, why don't we have that anymore? And I guess the only question I can think of is like just choice and complexity maybe is one thing, or maybe it's even like, maybe narrative is the thing here. It's like like as you brought up, we were taught this narrative that recycling handles most things, and it's only this gradual awakening that people are realizing, oh, so little this actually gets recycled, that we've like let ourselves dismantle these systems that kind of do exactly what we wanted them to do because we sort of believed this narrative for too long. So I don't know, it's an interesting like cautionary tale. It's like, is your narrative like misdirecting people away from things that they should maybe be continuing to think about? Like, should we be thinking about the risk of the risk of the nuclear reactors killing us while we're thinking about how we're building our city around them? It's I don't know, it's interesting things to juggle them all in your mind at once.
Well, I mean, I really liked it. That Park managed to monetize his, of all the projects, he created a revenue stream and made it into a gig system as well. Like just
yeah,
like I can monetize this from every end. Like I can, he's like, I gotta close the loop, but what he really did was monetize the loop. Like make sure that each part of it is, because the milkman, he wasn't scrambled, he wasn't app based. Like
he wasn't on demand.
Yeah, he wasn't on demand. He didn't operate at scale, like at city scale.
Yeah, Park, actually, you're going to have to fund all the subsequent workshops. So this is how it goes. One lucky person builds their idea.
I have one last comment for Park's project. I think that it's a great idea, and I think that it should be like further developed in the sense that like you should also consider what are the consequences of, for example, for the delivery of the food, and then for the delivery of the not the delivery, but like the phase in which you pick up the plastic object the packaging that you just used, because that creates more movement, and that creates like the use of like other vehicles, and as a consequence, probably you should think about like how to reduce that, because that's another layer of these of the diagram that you should create. And so probably it will be better to collect all of the plastic packaging that people use, and then like pick it up in a with a slower pace, and then like reduce the consumption of not reduce the movement of vehicles in the city, instead of like increasing it.
Well, I have a question about that. Oh, Nara, you gonna go? You go ahead.
Oh, it's fine. I was going to say it's for the past project this class has been presented, like all the training to me, it almost seems like they're focusing on the object itself, but these three projects are actually focusing on the relationship between the trained object and then the distance and everything. Like I just wanted to give plus to that, because I always love a different perspective on seeing things. And yes, Park, build the app. You're gonna be rich.
I have a comment for Park, but I also have a comment for the Cyclogan results that I'm seeing here, which are pretty accomplished, which is super good. I'm so happy to see that. I really appreciate Dal's image on that he synthesized in a way. I don't know if that's a raw output from the Cyclogan, or you just managed to give a personal touch and Photoshop on all that. But I think that image is, as an image, it's super powerful. So congrats on that. And a super kind of, I don't know, dumb comment on Park. I've been working with the university and the city in a project pretty similar about getting the industrial waste, not only on plastics, but also in other kind of like metal parts here in Rosario. It's pretty common, and all that, and trying to upcycling them, trying not to apply a new process of transformation, because that's gonna add another layer of energy consumption, also CO2 emission and all that. So what if we start training AI to understand how waste behave, and they can be directly applied to housing, right? Or housing parts or new products made with direct waste, and try to this is something that we've been discussing in SARC so far, right before I get back to Argentina with David Rui. I remember who else was there, but the new aesthetics that we are gonna have to engage with trash, right? So I really like these new products you make for reusable plastics, but also maybe we can start think about new ways of using waste in nowadays objects without adding a lot of extra energy to them, right? If not, you have these beautiful energy plants that DAO and Sub made for you, so you can use that energy too. But yeah, I think that's something very interesting to do. The other thing you have to think about is this is not a project about plastic. This is at least for me, I get it this way when I presented this project to the municipality and the university here in Rosario, which was, this is a project about logistics, just logistics. At the end of the day, you are upcycling, or you're recycling, and you're reusing plastic, but it's more like a logistic project than a project about waste, which it is the main subject, but it's not completely about that. If you start balancing, which is having more weight on your balance, probably logistic will take like a bunch of your project. You're gonna have to deal with it. Just to sound clever at the end of the day.
Yeah, no, I actually
great project, guys.
I love that you're talking about logistics and aesthetics in the same breath, because I think that's one of those, formalism deservedly getting a bad rap, and I think that, these days, and I think that makes a lot of people shy away from aesthetics. But there's something about, like, if you want to think of the cycle again as a study of aesthetics to a certain extent, where you're studying it as a visual manifestation of logistics and the aesthetics that emerge from that, rather than the other way around. So I think there is something really powerful about simply looking at how do these narratives or these logistics we create manifest themselves visually so that people can understand them. And again, maybe that's part of the strength of the upcycling project as well, in that it's by sort of localizing it and reconnecting you to these things where you're telling someone, pick up my dirty dishes, and they're coming and getting it. You're taking this thing that normally is the sewage pipe, you put it in a hole and it goes away and you never know where it goes ever again. And it sort of re-visualizes it. And then in some ways, what I really liked about your project is it's actually reimposing that back on the city. You're saying the city needs to have more small courtyards where this can happen. So you're sort of embedding this in a sense, this moral stance into the actual structural fibers of the city, and creating this way that it can be sort of sustain itself and encourage itself to continue. So I don't know, yeah, the aesthetics of this are really, really powerful, and I really appreciate your comments, Pedro, on these.
Yeah, actually thinking from a urban design perspective, I was learning urban design back in Copenhagen a long time ago, and the way the Norwegians, not Norwegians, Scandinavian people deal with urban design is literally do a lot of research and talk to a lot of local people, like, and basically persuading them they're doing the right thing without any like concrete proof or data sets. But like through this workflow, especially the simulations are really translating a positive language to the local people, I believe. And one thing I learned from the urban design is people are actually way adaptable than they think they are. So if you just have a way to persuade your idea, and it's something is going to happen, and people's going to either love it or hate it, but at least you get your you're getting your ideas and the data across. And for the aesthetic in design, I'm not really into second before, but like I believe that this our conversation, also the students' presentation, made me realize that the importance of like getting to understand what an image means, because there's so much of the background story attached to an image, which seems very superficial from beginning with, but after when you reveal it and then match them together, and then like the data is times data means more data, and then you're like all the beautiful references and all the images doesn't necessarily just means they are beautiful, but there's this underlying tones and reference and history behind it. I think that what makes this type of workflow and projects extremely powerful.
Yeah, that was the plan. that I think you just hit on exactly, like, you know, we've all seen enough abstraction through machine learning. It was like, how can we use world building tactics and kinds of things from the narrative realm to put meaning or put information back into this, you know, data by itself, you know, that without making information of it. How can we build a story out of this? And, you know, I think it took a little while to kind of click, but once it did, you're like, yeah, no, that's the point, right? Like the image is, in some respects, it's just, you know, scrambled eggs sometimes, but you can give scrambled eggs meaning if you think about it long enough, you know, like there's an exercise in that's just useful in general for everyone, you know, the power of a good story.
But I mean, even if sometimes the image doesn't, it's not like exactly describing what we are, like the discourse that we are following, it's that's what speculation is. And it's very important for going ahead, for making steps forward. And we need that kind of stimulation. And that it has always happened in the history of humanity, like of the humankind. If you think about it, like architecture works through speculation, has always worked like that. First, we had like just sketchers and artists that were like helping us to stimulate that part of our brain that was producing ideas and then communicating them. And then like we had the cinema, movies, and other things that we could look at. And I think that like now AI, CycleGAN, or whatever method we choose to create new images that can simulate us, even if they have like not very specific information in it, it's very important to build ideas and to actually then go towards that other upper level of like the actual implementation of those ideas. So this is important.
So we were actually like kind of inspired by this thing that I've only taken one architecture course in my entire life, and they were talking about this thing called the partie sketch. Like, I guess it's kind of an antiquated thing in terms of the way you guys practice architecture, but like, so we went and looked it up while we were in the, and you know, it's like just this kind of rough rudimentary diagram thing that, you know, the architect would kind of sketch out. And I was like, that's what this is. It's like, you know, but we just don't use pens. Now we just use machine learning and intelligent agents to kind of party sketch out an idea, like it could be this. Nobody's saying we're gonna, build and design an app from this, but like we have new tools, and new tools allow us to think at different scales, and we can sketch in different ways. And then, it's that great John May, kind of idea. There's no, no pre-technical thought. Like what does having these tools as opposed to having a ballpoint pen do for us in our intellect, in our design thinking? So once we found a relationship to architecture, which took a minute, then we got back in it. We're like, okay, it's just a sketch. It's just a machine learning enabled design research sketch. So,
well, it was also a funny thing to be doing with a 9-day workshop, because there wasn't really a chance to go back and restart the project where you would have that opportunity, in a semester-long project. And I remember Seth saying like, well, based on what he's getting from CycleGAN, like it makes him want to change aspects of the ideas. Also, as an aside, because I really want to bring it up, like on his first try for CycleGAN, he basically like made Seoul into the suburbs. Like, I have it. No, not that one. I sent you the wrong one, Pedro. But it was like this, but all green. And we were just like, how did you do that? What? Like, how do we make that into a project?
He turned Seoul into Phoenix, Arizona.
Yeah.
I thought that you just sent me the wrong one.
I know I
was
did.
like,
Sorry.
Oh, okay. Let's make it clear.
Yeah, I mean, and I think it is one of those like valuable things. Like people have in architecture, I feel like these GANs are typically thought of as these like finished products. It's this whole thing, and it's just like it's so not. It's where the thinking happens, and we've like trained ourselves to read our intermediate. Like we can look at some chunks of plastic in our hands and understand that's an expression of thought, but for some reason for the past few years a lot of people haven't felt as trained to just look at an image that can look so polished and so finished and still think of it as something kind of malleable and workable. So like I appreciate workshops like this where you're like reinforcing that kind of aspect of these images.
Yeah, actually, through my collaboration with Laura, there's one question being asking each other is, what does this training means, right? Like to some degrees, at least for me, I was trying to find a meaning behind a train, and but right now I feel like this project made me feel like the meaning behind a train, or as what Case was talking about, the partie diagram, has the meaning that whoever designed it applies on it. It doesn't really matter. Like literally you brings the ideas to the project. It's not a purely AI project. There's a human layer, there's human culture flavor to it. And then that what makes a project, and that what makes a good story a good story. And love how we ended up as layering up the party and the drawing itself.
Yeah, where are the like unrolled elevations for this? I'm struggling to understand what we're looking at.
Architect.
Yeah, we had if you'll remember, out of 9 students, we had 1 section. So,
Also, neither me nor Laura are architects.
I know. You have 2 non-architects teaching a workshop. What do you think is going to happen?
Yeah, you're gonna get something different. Yeah, I mean, whether that's good or bad is all wholly up to you. But yeah.
Oh, well, do we have any final comments about projects, workshop, general feelings? I don't know, from the students as well. You guys feel free to chime in as always. Oh, well.
I will go. I think that Hernan Diaz Alonso, which is SARC's principal or director, I don't know what the name, would say 2 things. One, if architecture, what Raquel has said, architecture is a CEO. Okay, got it. Architecture is an act of optimism, first of all. We architects are pretty good at misusing tools in things that we can speculate with. So I think that this workshop taught by 2 incredible non-architects persons is specifically what you need to break the ice or break, you know, your I hate saying comfort zone because it's so tricky, but my English is so bad at this time, so I cannot find another phrase, just that. And I'm using that phrase just because of that. But yes, I think that all the results that we saw here was more like trying to speculate on things. But the most important thing is trying to think out of the box in terms of politics, in terms of society, in terms of landscape, in terms of how to engage cities, landscape, persons with infrastructure that at the end of the day would probably save us from the big hole that we are in right now. So engage society, engage with your ideas, try to think out of the box, try to be optimistic about it. First of all, have respect with all these tools, misuse them, and try to figure out new borderlines where at the end of the day is the place that you have to stand on, right? The borderline, always. Just that. Congrats on the work. Well done.
I'll leave with one quick thing too. I just want to point out that what you're working on is not trivial and not important. It's extremely important. The largest shift in American politics was when when they constructed the interstate system. And if you look at the map before and after the interstate system, all of the states that were used to be more conservative became more liberal, and it was the largest push of liberal movements in the history of the country, and for that matter, technically the world, except for possibly the Roman Empire and when Genghis Khan was going through Europe. But what I bring that up is to say that not only historically, but in recent memory, infrastructure has played an immense role in politics, and that's why there's so many companies and corporations really interested in the works of infrastructure right now, because there's a lot of potential gains to be made within that world and money. But what I would point out is that though at the cultural level, sure, the politics changed the United States, what also happened is it gave rise to the modern day pigeon, because all of a sudden pigeons were able to cross the country in ways that they were never able to before. And so not only was it a extremely political divisive move to do, but it was also something that forever altered the ecosystem of the United States. And so all of the things that you're working on have the potential and most definitely will cause those kinds of things if they come into real life, or into fruition, sorry. And what I would say is that almost every billionaire is trying to go to space right now. Almost every single energy company right now is trying to figure out ways to create energy that's more efficient. These are all things that are doing, but nobody's figuring out what happens with those pigeons that we've created. If you're able to find paths of weird things that these infrastructures are doing outside of just our realm, and how they're manipulating and changing the ways in which our cities work with non-human agents as well, I think you'll be able to take that off to the races and turn that into an entire project. So anyway, amazing work. I think it was an ambitious 9 days and it was successful. So great work.
Yeah, about that, I'm sorry, I'm not sorry that it was very ambitious, because we asked a lot from you. This is a massive project to undertake that people would spend lifetimes researching and trying to find a way to implement, and you did so in 9 days with all new tools. So I'm so proud of you all, and thank you for a really fun week. And then, of course, thank you to the jury for coming. Really appreciate all the comments.
Yeah, thank you guys. Thanks for coming out. And it was really fun. It was good times were had by all.
What's the point if not, right?
Well, that's the way I feel about it. But you know, you'd be surprised. Some people really want to punish themselves. But
oh yeah, no, great work. I mean, if you just get a little bit of this from this workshop to a thesis project, these 9 days were worth a lot. So